So we have discussed previously about the systems of linear equations and about the consistency and inconsistency of system of linear equations, and that the consistency or the system of linear equation is called consistent when there is an intersection, at least one intersection, between the lines that represent the equations in the system. This means that there is a solution for the system of linear equation. And as we remember, the system is called inconsistent when there is no any intersection between the lines that represents the equations in the system of linear equation. So this system where the lines are parallel, they are not intersecting in any point, and they will not intersect in any point even if we extend the lines. So this system is called inconsistent. And inconsistent means has no solutions. So with linear systems of equations, there are three outcomes we have to deal with. First one, well, there is a single solution for the system, only one solution. And the second case is there will be infinite number of solutions for the system of linear equation. Number three is when there is no solutions at all. There are no solutions at all. Let's discuss each case alone and see when and how. Okay. Case number one, when there is a single intersection between the lines that are representing the equations in the system, so there will be only one solution for the system, single solution. It can be more. Let's find out if this is x and y, then if this line here represent an equation and this line here represent another equation in the same system, then they are intersecting in one point here, and this system is consistent and has only one solution. The second case, if both equations refers to the same line, then, for example, the first equation represents this one. For example, y equals x. The other equation in the same system is y equal to x. Okay, so y equals to x will be like this, minus x. And if there is another equation that is representing the same line, in this case here, both equations are representing the same line, then there is an infinite number of solutions here for the system. The last case, when, for example, both lines are parallel in the system like this, they are not intersecting in any point, then this case I can say the system is inconsistent and has no solutions at all. So here is one intersection, then there is one single solution for the system. In this case, two lines, or the lines that representing the equations in the same system, are parallel. They are not intersecting in any point, then in this case there will be no solutions for the system. And this one here, when the both lines, or all the lines that all the equations representing the same line, then there are infinite number of solutions for this, because they are identical actually. Let's see some examples. Now, how to decide how many solutions are there in the systems of linear equations. So, how many solutions do the following systems of linear equations have? I need to represent both equations on xy axis and see if there is any intersection, and if there is one intersection, then there is one solution. No intersections, no solutions, and if they are the same line, then I have infinite number of solutions. Let's take a look here. The first equation, when y equals to 2x. If x equals to 0, then for sure y equals to 0. Then I have the first point 0, 0, the origin. There it is. If x equals to, let's say 5, then y equals to 10. I have another 5, 10 point. So let's represent it's 0, 0 and 5, 10. Here. Okay, let's see here. No. This is supposed to be here. The other point here, if x equals to 0, then y will be, when I substitute 0 here, y equals to 9. The first point is 0, 9. When y equals to 0, then x will minus x plus 9 equals 0. Then 9 equals to x. The other point is 9 and 0. This one here is 9 and 0. The other point is 0 and 9. So when representing this, roughly we will find out that there is one intersection here, and this system is consistent and has one solution. Let's take a look on another example. X plus 3y equals to 3 and x plus 6y equals to 6. Let's take a look on this, and I need 2 points on each equation. For the first equation here, when x equals to 0, then 3y equals 3, then y equals to 1. So I have this point 0, 1. When y equals to 0, then x will be 3, and I have 3 and 0. 0, 1 and 3, 0. The second equation, when x equals to 0, then 6y equals to 6. So y will be 1. At this first point, 0, 1. If y equals to 0, then 2x will be 6 and x will be 3. So the other point will be 3, 0. As we can see here, both equations representing the same line. So in this situation, this system of linear equations, we have infinite number of solutions for this system. For the last example, y equals 3x and y equals to 2x plus 1. So let's take points here. When y equals 3x, when y or x equals to 0, then y equals to 0, I have a point 0 and 0. When x equals to 2, then y equals to 6. I have another point 2 and 6. Then 0, 0, 2 and 6. For the second equation, when y equals 2x plus 1, if x equals to 0, now y will be 1. So I have this point 0, 1. If y equals to 0, then 2x plus 1 equals to 0. So x will be minus half. This one here is minus half, and at this point minus half and 0 and 0, 1. Zero, 1 will be here, and minus half with 0 will be like this. And let's see. As we can see, obviously, this system is inconsistent, and there is no intersection between the lines that representing the equations. Then there will be no solutions for this system of linear equation.